Hello and welcome to a new session on Hitchhiker's Guide to the Glamorous World. And today I am joined here by Siva. Hi, Siva.
Hi, Tudor.
How are you?
I'm well. It's a nice day in California.
Is it? Okay. Glad to hear. So you were showing interest in Glamorous Toolkit recently. When did you start working with it?
Maybe a few months ago. I'm not sure how I came across it. Maybe one of your presentations that I saw the video on YouTube, talk that you were giving about moldable development. I think that might have been the context in which I came across Glamorous Toolkit. And
Interesting.
got me quite interested because I've been looking into related ideas for a while now. So, and I was aware of Smalltalk, seen a few demos, but never used it myself. Yeah, so
now you have a good excuse.
Sorry?
Now you have a good excuse to learn Smalltalk.
Exactly. So, yeah.
So what would you say, what is moldable development for you?
So the fact is that we spend most of our time with devices that are supposed to be general purpose computing devices. Whereas in practice, most of our experience is shaped or nudged by certain use cases that are already provided by apps, right? And if you go off that specific path, suddenly it feels like there's nothing you can do. It's almost like there are guardrails that will keep you within that and nothing outside that. So to me, moldable development means a lot more freedom in practice. So I can configure my computer usage to my operating flow. However, I might want to creatively express myself or go about my activities. And most of the time, the standard use cases might be good enough. But I feel that often enough, I need to do something that's different from common. So that's what moldable development means to me. Like as a user, having that freedom to quickly reconfigure certain things and doing something different or doing what I want to do.
I see. Okay. So I think you recently asked a question on in our community Discord about how one goes about creating these slideshows, right?
Mm-hmm.
So here in Glamorous Toolkit, first right on the home screen, we have multiple entry points, right? So some entry points are the tools, some entry points are these live slideshows, and then we have documents or at the bottom. And documents like this, right? They are programmatic, right? They are not static things; they are living things. So we can go inside one of those. So if I now go here, I see this is a piece of text, and here at the bottom, there is a menu through which I can go and change the different navigate through my slideshow. But at the same time, I can also here there's a toggle which says, well, let's browse the slide method. So all of these slides, they have a code representation in this case. These are methods. So I see here a method titled slide 4, and I see a class, GT Tour. And the method here is simply annotated with a pragma called GT slide. And then I get here a kind of a stream that knows how to compose these kinds of slides. And then there I would say, I want the title slide. And this one has the title slide gives me an API of title with format or subtitle with format. And basically that's it. So if we maybe change this one and save it, then it gets updated there. So that's the essence of how one goes and create this one. Maybe we can create one from scratch just to see how it is.
Yeah, that'd be great.
So the way we do it is, so these slideshows are just normal classes. Let's say I have here my slideshow, And of course, this is my slideshow. It doesn't exist. I'm going to create it. And so here it says, I don't have this, I don't know this class, so let's create the class. Maybe I'll put it in my slideshow package as well. Sorry. So when I inspect this piece of code, I get an object, an instance of my slideshow, nothing complicated. But if I give this object to a player of slideshows, so if I say here, GT live show create, and then I give this instance to that, what happens is that I am, GT live show is like it's a player, and it gets any object. And here, because it didn't find any slide, it automatically created one. So it created a class here, a method in my slideshow called slide1. And at the moment, the slide is just an empty slide.
I see. Simply because GT Live Show expects some such method in order to be able to display?
GT Live Show expects that one, yes. It expects that there is at least one slide, and if it doesn't exist, if this one slide doesn't exist, then it offers one, just so that you have what to start from, right? It's the same thing that happens when you open a slideware tool. The presentation will always come with the first slide. Yeah. So that this is where you start from. And that's basically the idea. And now, okay, so how do we go about, adding something to it? And we have a bunch of slideshows here so that people can go and inspire themselves. And by inspire, I mean copy paste from. So here is, right, let's say that I like this title slide. So I'll copy it and I'm simply going to paste it here. And as I execute that, I'll get my title over there. So, but now, of course, it's my slideshow, and let's say slideshow is going to be bold now. And I'm going to say here a demo. Okay, no, this one, like this. This is better. My slideshow, a demo. Okay, so now we have a little slide. Okay, now in this moment, maybe we can add now another one. So we have slide number 2. Now here is what do we want to put in there, and that's one of the properties in Glamorous Toolkit is that everything that we render is is relying on a single rendering tree, which is simply a tree made out of elements. And basically, at any point in time, if you want to affect something in a scene, that's what you will create. You will be creating elements that will eventually be placed there. So this, if we go to this slide here, if I say here a slide title, eventually this actually creates a set of elements in there, right? So that's it. Okay, now very often we want to have something like a playground, for example, there. So just so they have, we notice that a lot of our sessions, for example, when we want to explain code, or we usually start either from some sort of a document, maybe from an inspector, very often actually from a playground where we can play with variations and do some live demos in that way. But these are, to a good extent, larger classes of slideshows. So let's go and find some of those and see if we can inspire ourselves from it. So, okay, this is not nice. This is some custom thing. Okay, this is the one about where we're describing what moldability means, right? So it's this idea that if I have objects and they are all generic, and I see they all represented like all inspectors represent objects, that is showing me the inside of the object. But when I want to relate to an object, it's much more interesting to look at it from the outside. So if I have these kinds of views, then I can relate myself differently to those objects, right? And this is why we have these inspectors with different tabs. Now, what's interesting about this is that if we want to look at how this one is implemented, we'll notice here that this one actually delegates. It delegates further to something else. So here we have some kind of a wrapper, label plus element.
Okay.
And this element block over here, it expects some logic that will return an instance of an element. So in this case, it's just a custom scene. And what's interesting here is that we have wrapped, so we have another slide, which is called GT All Live Slideshow. This one, this GT All Views Live Slide New. So if I'm executing that one, just this one, I get the slide, but without the label on top. And because I can simply tell to this one, or give me your element, so the actual thing that will get rendered, which is of course visually the same, but it gives me that element. That's why I can simply put it in there, in the upper one. Okay, so this is at the moment how we are composing slides. So let's see a bit more. Okay, this is some piece of text here, right? Notice how this one is called text and element. So this is another pattern that we noticed that we basically need to rely on a lot. That is some sort of text and then some view over the element, right? And then you can change whether the element has more weight or less weight, kinds of things. But okay, here. So here, for example,
which elements, like which slides become the elements for that process? Like, how did we choose the 6 slides or the 4 slides that are being embedded in this way?
There is this priority.
Okay.
So every slide has a priority, and that's the priority that will inform the order in the overall slideshow. But the idea here was to simply have a very basic mechanism at the moment to have a slide in a method so that you can easily copy it from here, put it there. Because very often we notice that you need to, use similar visuals, but support different narratives. Because when you give presentations, you don't want to hard code too much, text in them, because that's not the point. And so it's very often, like, we are actually just, when we're giving a presentation, we're going to say, okay, what is the context of the audience? What is the thesis that we want to say? And we're just going to say, oh, this one, this example, that example, and we'll put it there. In fact, it's an interesting thing. Often when we give demos of Glamorous Toolkit, people say, oh, but you've picked some very, very specific, very good demos for that, for that presentation. But what is difficult to convey is that, in fact, the way we are giving presentations is say, what was interesting the last week, and then, or the last couple of weeks, and that's what we put together, and that's what we tell. But so anyway, and that's the process. So we kind of created this one. It's not a very complicated thing. Ideally, we would like to be able to edit the slides directly with direct manipulation, and so, which is, that's clearly something, clearly a direction we want to go towards. But until then, we just wanted to have something basic that is good enough for us to, just to support normal or reasonably support in some pragmatic way this flow.
Sessions like this are actually quite nice to convey that point, because the thing that we're discussing now is something that I asked you about only a few hours ago. So you could definitely not have had a chance to prepare for this.
No, yes, indeed. So let's see. So there are a couple of things here. For example, here there's we were looking for a slide with the playground, and I know that here in Faro 101, in fact, here we have a whole tutorial of Faro 101 that is essentially all happening in the playground. So just a bunch of playgrounds plus a little bit of narratives over here, and that's the tutorial. So if we look at this one over here, okay, we can see that this is there's an interesting thing here, which is that there are some explanations that that link to this to the playground. This is a little bit more complicated. We can come back to that a little later because it actually requires. This is this is the most kind of complicated scene that we can end up creating to be able to build these types of live views. We can come back to that a little later if you want. But let's find something that is maybe does not have these types of things. So here, if I'm looking at this, I can see that this is much simpler. So I have something like a GT Playground live slide. So, and I'm just going to give some snippets to that one, and that's basically it. So let's start with that one. So we go to our slide, and I even think that there is here a playground, but let's just do some. So here, if I say I want an element, and then the element here should be produced in some form, and if I execute that, then I get the element in the slide. And so these are the different snippets that I have and so whatever I put here, that's what gets there. So now I have two slides. The first slide is, let's enable the navigation. The first slide is my title. The second slide is a playground. And then of course, this is now a full playground here. In that you can go and you can navigate and go on. So it's the beginning of a reasonable, an interesting. It's usually the way we are setting up presentations very often is we're just creating the start points, and then during the presentation you're going to follow up with 2, 3, 4, 10 different interactions for every slide. And that's pretty much how it goes. Okay, so are there questions so far, maybe?
No, I think mostly I follow what's going on. So basically, if I were to summarize, you have this thing for creating slides, and then this sort of element to view it. And then within that, you can embed other slides or snippets or things which become elements that are then displayed on the slide.
Pretty much, exactly. That's it. Right, so, and then of course, so here I have now just an element, and let's say this is useful when I'm giving a live presentation, because when I'm giving a live presentation, I don't want to see anything else. I just want to see just my slide, basically, and nothing else. But if I want to now transform this one into a little tutorial, like I have here, then notice how I'm wrapping the playground into little something else, right? So if I copy this and I go here, then I have here a text and element, and I'm saying there, okay, let's have some text over here. And maybe I can say Glamorous regular font. And then I can say, yeah, well, something like this. So this is some text and so I'll expect now to see some text over here, and then let's maximize that. Then I have the explanation on the right. See here, font size. That's it. So that's pretty much it. This is how we construct slides. And then, of course, if we now go and take this slide, for example, and we browse it in Coder, you'll notice that this is a class, and there's a hierarchy of live slides. And these are essentially, you can think of them as templates, but we think of them as simply convenience, constructors of slide scenes, essentially.
Right.
And that is pretty much it. And it's quite simple. In fact, all these slides, they have they are something we call a stencil. A stencil is we can think of it as a factory of elements. And essentially what they have is they have a method which is called create. So all of the subclasses will be, all the concrete subclasses will be, for example, here I have the class code of live show, and this one creates, overrides the method create, and then it shows it builds at the end it returns an element. That's what it needs to do. And the same thing happens with the playground live slide. If we go look at it there. So here the create one is a very simple, just playground create new. And that's it. Now, when you're creating this one, of course, you can go directly and create code. You can write all this script in the code. So I don't necessarily need the whole I don't need a whole playground live slide necessarily if the only thing I want to do is something like this. I think that should be it. So let's go and inspect that. Right, this is an empty slide. That's great. So if I'm now saving this, I get an empty slide over here. Okay, in this case, it's empty because it's not good. It needs at least one snippet in there for it to say something. So I can say here, you can say, okay, it's new default. That's a better one. So and if it's that, then I have this slide. And so in this case, I did not use a slide or a slide class. I directly constructed it myself. But sometimes if you want to reuse it in multiple places, then we'll find ourselves creating these kinds of live slides. That's it.
Okay, so if I can ask, if you'll indulge me asking like some silly questions about
presentation.
Right. So if I wanted to, let's say, add a video or maybe theme my slides, like presumably there will be like I can edit the template to have, I don't know, all text to be in some color or something like that. Like, would those things be?
Yeah, I just did one here. And if I say foreground, I suppose I can say color red. That's horrible, but.
Could I make this change in the template so it'll apply to all slides? So will I just go to the sort of base class and make the change there?
Yeah, there's nothing. These are all just plain objects. So if we look now at what is text and element, text and element is going to be here a method, which is just a utility method that creates a text and element live slide. So if I browse this, I will see here that I basically have something that creates these elements and then takes two things as an input: the element, which is just a block that will return the element, and a piece of text, and then it constructs the scene afterwards. So you can actually construct this scene yourself.
What do you mean by, yeah, so in any special case I can, but I was just curious how I would sort of make the change that would apply to all slides as a template maybe.
Well, here, if we, let's say if I'm, where is it? So, well, we can go here and in this new text format, and let's enforce here that the foreground is let's find something obnoxious. So it's color magenta, right? So now if I'm refreshing this one, oops, I think I didn't understand something. I was doing it in the wrong place. So, okay, let's try again. Right, so now I have just changed all of those, and this means that if we are going to go now to some of these, where we are using text and element, we should be seeing magenta as a color.
Great.
Yeah,
And so basically you changed the default in that GT live slide or whatever class that was.
Yeah, in this case, yes.
Yeah.
But it's not advisable, but yeah, you can do it.
Sure. Yeah, I'm just curious, trying to understand the system.
Sure.
So
Yeah. Mm-hmm.
And like, is it possible to embed videos?
Is it possible to embed videos? At present time, technically it is possible. Do we ship an integration with the video player? No, there is no such no out of the box. There's no such integration. But the rendering stack is made such that you can embed any arbitrary surfaces that are being built somewhere else, anywhere in the scene.
Okay.
So, but practically at this moment in time, there is no out-of-the-box integration for videos. Other questions, maybe?
So could you explain a little bit more about what the priority
yeah, priority, it's just simply says what, so here I have two slides. So let's make this one priority 0. So now if I look at this one, this is first and this is not first. And because this one has priority, whatever it was, 1, and then this one over here has priority 0. That's it. It's just a number so that we can order the slides for now. Nothing complicated.
And so should I expect this to always have a linear flow, or like?
In this case, yeah, we didn't implement, like maybe sometimes you might want the graph, maybe with different options. And so we definitely have that one in mind. We think that these, we look at Glamorous Toolkit as being a platform for telling stories about the inside of software systems. So empowering people with storytelling tools is definitely important, or we find it important. So yeah, it is something that we have a particular, where we spend particular attention to. But at the moment, it's just this implementation just offers a linear flow.
Sure. Yeah, all of this is definitely quite exciting.
Yeah, well, it's reasonable. So we do not want to. The other thing about Glamorous Toolkit is that we're saying that this is an integrated development environment, and integrated means everything about it, everything about development, everything that relates to the system that we want to, or that we care about, has to be supported here, because otherwise, if I have to do something about my system and I have to leave, then the I in IDE has failed. So that's why we're basically saying every time we see, oh, we need this, okay, so it has to be here. And so at first, the models they are not necessarily as so elaborate, but at least the activity or the basic activity, or we want it to be supported. And so we're still covering the bases. Not everything that we want supported is supported, but yeah, that's the game that we're playing.
Sure. Yeah, in my case, I just thought this would be a nice sort of path to onboard myself onto Glamorous Toolkit, because it seems fairly simple and it should be easy to replicate based on the examples. So that was my motivation for looking at this.
I think it's a nice it's a nice idea, but it's also, the other interesting thing would be to pick a specific problem that you actually want to present, which can be what you learn. For example, it can be something that you would want to, that you can capture as a presentation, but it can be also something that from a domain that you might want to try to explain. for example. Yeah. So one thing that that is also like kind of related to this is how do we construct more complicated objects that come from a domain. And so playgrounds is one such input that we're having. Another input that it can also lend itself interestingly to having views are, so if you look at, for example, these inspector views. Oh man, what do we have here?
I'm sorry I asked you to do that.
That's okay. That's okay. We're gonna fix it. So here is, okay, we're gonna make, let's not have this terrible.
So by the way, since this is so interactive and we can change anything, are there sort of abilities to snapshot and undo everything that was done or roll back?
Yeah, so
like this that one might do?
Yeah, this, so if you go here, this is a Smalltalk. We are in a Smalltalk image. So Glamorous Toolkit is built on top of Pharo. Pharo is a Smalltalk system. And here, if we save, then you're going to snapshot the whole image, exactly with all the objects in exactly the state that we are looking at. And so, yeah, that's the snapshotting part. This comes all the way from the Smalltalk background.
And how do we roll back to a previous save?
Oh, you would have to kill this image and start the previous one.
Oh, I see. Okay. So if
you're basically
try something silly, I just need to do a save once and then I can do whatever I want.
Basically, yeah. Everything that happens in the image by default happens in memory. And every once in a while, you might want to persist it in some form. So for example, code, we do not save code like this. We always externalize code into some storage, some external storage. For example, now we rely on Git. So you would, but this is not unlike, for example, what would happen with a Docker image. So you go and tinker with a Docker image, and then you say, okay, now I want to persist it into the script that produces a Docker image, and that's basically how we work. So the practice that we're following is that we have probably built images like this multiple times per day. No, they're pretty much built by the continuous integration server, but yeah, and that's how you just take the latest one and then you work with it. And so we do not care. We don't want to rely on side effects that accumulate in an image. So the image has to be reproducible through code. So all the way, ideally, in the way you bootstrap the whole image. But yeah. So I was saying here, I have here these inspector views. And what you're seeing here is you're seeing an example of an inspector with a couple of objects here. In this case, is an instance of an address book, and here we just want to exemplify how you would create a list view in the inspector. And that's why we are only showing the list view. But in fact, this is a full inspector, but it's just trimmed for this specific example. And then here on top, you have the code that goes with it, right? So you can have things like that. So now here, this inspector over here requires an object. It needs to start from somewhere. And the question is, what is this object? So let's see exactly how this one is implemented. And so this is a little bit a more complicated type of slide, because here on the left, we have this rich text. And this rich text has a couple of links on them. And those links, and notice how the links actually match also in code and here. And this is actually live. So if I delete, for example, here M, right, the link doesn't go to that. And if I add E now back, and it goes back to it. So it's live. It actually happens live. And so this one requires a more elaborate setup, right? Because you need to tell these little dots over here are actually added by the syntax highlighting. So there's a special syntax highlighter that we install for this coder, this method coder over here, that when it finds a message called, for example, in this case, full name, then it will add this little dot over here, which is then useful for this. Okay. So, but let's take a look at a little bit at this example. So here I have the text on the left-hand side. We're not going to look at it at the moment. And let's look at the this thing that we're creating on the right-hand side. And notice it does take a little bit longer. It's a more elaborate because it is also a more elaborate scene. Mm-hmm. But somewhere here we say, well, we want here. We're using this object here. So we say GTAB cartoon address book example, and it says cartoon address book. So if I inspect that one, that's an actual instance of an address book. It's the same one that I have here. And I'm just in this view over here. I'm just showing this view. Uh-huh. So this is basically what this whole code over here says. Now, but what I wanted to talk about is more this one, because here I'm showing you an inspector, and the inspector already comes with an object. If I show you a playground, then it's enough to give you the code with which you will create the first object from which you will start exploring, right? But with an inspector, you start from an object, and the question is, where should those objects come from? And this is where examples come into play. So if we look at this GDAB cartoon example, and I open it in Coder, I see here that a number of them have these types of kind of dots. And these are these are examples. So we can run examples as if they are tests, like this. So I just ran here all these all the examples, and I can see that, okay, they are green. But at the same time, if I look at what is an example, so if I look here, an example here is that I'm setting something up, and then I'm asserting something, and so up to here it looks like a test, right? Mm-hmm. It's just here's a setup, here's an assertion, that's it. But the difference between an example and a test, the practical difference, is that an example returns an object. So why is this interesting? Well, this is interesting because in our environment, as soon as I have an object, I can start to have exciting conversations, right? So if I'm now, instead of running this example, I am inspecting the result. Then, this is that situation now. Oh, no. Then I should get this one. I should get the address book over here. Right? So there's a bug that we just solved. This should not exist here. This should appear immediately when you're executing the example. There should be the contact list. But this is that's the idea. The idea here is that we also have modified how we are writing tests such that at the end, the byproduct of doing normal TDD is that now we also have the pieces with which we can create documentation. Because if I have these objects, right, and I can weave them into my presentation, then it's very easy. I can just take from here, put it there. Here's an inspector, here's the view, and then you can create a narrative. And it costs very, very little. There is no duplication. You don't have the problem of co-evolution of documentation with code, because the code doesn't go anywhere. I'm just pointing to it. I'm not copying it anywhere. So. And it's very maintainable from that perspective. And then you notice here, as I said, like our goal was to be able to tell stories about the inside of our systems. And so not only did we create interfaces, but we are also creating we are also creating the engines underneath to give us the data in this case, right? So that's something to look for. So these example methods are simple, normal methods that are simply annotated with example, right? So here's one that we like to show a lot. These are some pictures examples, and this is actually an engine that works with the cognitive services from Azure.
Okay.
So it does face recognition given a picture. So if I have this picture example, it kind of does things like this. So given a picture of in this case of Einstein, then this is how landmarks will be represented. So this is an example that says how it's, so we need to work with the Face API from Azure. And then from the Face API, we get some data, but we still need to model that data so we can represent it locally. And this example over here exemplifies how we are composing this local, once we get the data, how are we displaying it locally, right? So we can have things like that. And then from there, you can have various types of various kinds of, you can navigate from there further, right? So, and that's the basic idea here.
And so in that case, so how do I inspect the data which represents those lines and dots, like the landmarks and the connections on Einstein's face?
So let's see here. This is a more complicated situation where we have this is a picture of three people, and then all three of them are detecting as being, their faces are being detecting as like this. And you're asking, how do I get the objects behind this?
Yeah.
So if I have this, right, this example, how do I look inside? So let's, this should not be like this, but okay, we get that. So what is this? Okay, this one is a CS picture, and it says, well, I have also these three faces. And if I look at the faces, in this case, the faces do not come with landmarks. If the landmarks would be added as well, because there are different ways, different data levels that you can get in the model. So if you have those, then it will be presented here. Otherwise, at the moment, it's just you just get the end result of it or so. And but this is basically what you do. And at the end, it's very simple, right? So it doesn't matter how complicated the algorithm is. At the end of the day, all it does is just produces a data structure. And the data structure, once you can conceptually visualize it, then that is it. And then, of course, it depends on, so for example, here you'll have a picture, and then you wanted to say, okay, so I want to be able to draw the results, right? And then the result says, well, you get a collection of rectangles. So, okay, but those rectangles represent a face. Okay, that means that we need a face object. So then we have created a face class, and then we instantiated those faces every time we get the result from them. And that's pretty much it. This is how it works. Right. And in this case, we are documenting the result that we get from the algorithm, right? But sometimes let's say, I have a nice example here, I think. Yeah. So in this case, this is an example that actually says how we are constructing a tree map. So here we are actually documenting the algorithm, not the data structure that it produces, but the goal here is to describe how we are building the tree maps. So, yeah, right, and yeah, there. What happens when you have this? What happens when you have leaves of different sizes, and so on. So the purpose of this one was to document the algorithm, not the data structure. And notice how, in this case, we also just simply relied on inspectors because, and to do that, we are representing the steps as first class entities. So the algorithm doesn't just implicitly is a function that does something in there, but rather the algorithm says, okay, now here's a step, there's another step, there's another step, and at each step, right, I can visualize it. And if I have those steps explicit, then it's very cheap then afterwards to visualize. And once I can take multiple of those snapshots, I can build a narrative out of it. And then, of course, maybe you want an animation, but it's candy on the eye, but it's not particularly informative. So kind of like this. There's another one that just, I think, yeah. Squarify. Maybe this one. Yeah, so this one is also another algorithm, also about tree map, about how do we squarify it. So notice here, it says here like I add the first node, it's going to be like this. I'm adding the second one, it's going to be like that, and the third one, and it tries to position all of them. And then eventually it describes how, this one actually fits here. And so this is the steps that the algorithm take. So green is success and red is failure. So kind of like that.
And so this is basically the algorithm that controls how rendering is done in Glamorous.
How this squarified the squarified tree map computes the position in for Glamorous Toolkit, yes.
And like our tree maps, like the data structure that represents basically any documents that we want to view, or is it a specialized application?
Like a tree map is this visualization. No, it's a visualization layout. It's an algorithm of representing data in a 2D.
Right. So what I'm trying to ask is, so this visualization layout like this that uses tree maps, is this used all over the place or only in certain specific cases?
It is used in certain specific cases. Yes, I mean, you haven't seen any tree map until now. Like there was no, they didn't appear anywhere.
Okay, that's what
Just this is one of the layouts that comes with the graphical stack.
Okay.
And so we explained we explained it like that, and that's it. So yeah, I think another one is this one, for example, is another. This is another case where we're having so here, given C1 and C2, if you're doing a circular tree map, you want to find where to position this one, given C1 and C2. So this one then draw itself so that we can debug the algorithm. What's interesting is actually we use this for debugging purposes. So here is, when you're debugging an algorithm, it's very often that you're actually using a debugger just to figure out the steps. And then in the debugger, having you see on the right, the visualization of the object that you're looking at is then very informative and helps with finding bugs. And we actually created this view because we wanted to debug. So this is one of those cases. interesting enough, this kind of thing also appeared in a paper. So we actually took the visualization that came in the paper, and then we transposed it into our into Glamorous Toolkit, so that we can have the same representation, that the same mental model that people that created the algorithm had. We wanted to use the same mental model when we were debugging our algorithm, right? Because
so you have it throughout the development process for checking rather than just at the end as a verification. So yeah.
Exactly, and this is key, right? We are saying that as soon as a human deems a representation about a software system relevant, then it's the responsibility of the system to carry that representation forward. So in our case, somebody communicated to us, here's the algorithm. And then it says, here's how you can form a mental model about how that algorithm works. We found that one to be useful. Because we said, okay, now I understand how the algorithm works. Now I just have to transpose it into code. But then that mental model was still the picture. So then that's why it's the responsibility of the system to carry it forward afterwards. So yeah, and so once you have, because we have now, you have a lot of these examples, it follows that these examples are also pieces that you can simply take and say, I want an inspector for this. Yeah, I just want to, I want to quickly just embed it over here, and that's it.
Yeah, now I'm starting to understand your point a little bit better about how basically these are tools to construct narratives, especially when they are narratives to do with software or code that we're writing.
Right, or it can also be data. Because nothing stops us. It just so happens that in a small talk world, code is represented as an object, the data is represented as an object, everything is an object. So because we can just simply work with objects now, as soon as we represent something as an object, then boom, that's it. I have a tool for it. And that's why it's for us so easy to do things such as analysis of other languages. Because once you represent the other system implemented, maybe, I don't know, in Java or JavaScript or so, once you represent it as an object, then you can go and visualize it.
And so in practice, how would that happen? Like, is there some class or object that will import the code as data, or are there like ways to use libraries from other languages, or
code from other languages? This is what you're asking now. Okay, so let's go and find a piece of code. So this is now I'm inspecting the file system. And so because this is a file reference, it shows me the items. I can go and dive in there. So the inspector now has just transformed itself into a kind of like a browser, right? And here, for example, I have package JSON. So now this is a JSON. And let's say that you want to care about, that's a nice demo that we give often, is here you have dependencies. And you want to count how many of these dependencies are coming from React and which are not, right? So how do we do that? And we definitely don't want to read, right? That's definitely not the answer. So, okay, so how else? Well, so one option here is to say, well, given that I already have a JSON parser in the image, if I say here self-contents, this will give me, let's see, if I evaluate self-contents, it gives me the byte string of this file. Self is the file, so self-contents will give me that. And if I parse the JSON, I'll get my dictionary over here. Right. So now you can see I have here dependencies, and I can start to look at them like this. So if I say at dependencies, I'll get those dependencies, right? So now that's a dictionary. And if I say to this one, because I just care about the keys,
Right.
and that's going to be an array. And now if I select from here, each is, let's say, begins with React, then I see that there are 23 of them, right? And if I reject that, then I have 17 which are not coming from there, right?
Yeah.
So, so I've just transformed something that is otherwise perceived as a text problem. Why? Because where do people look at this JSON? They look at it in a text editor. So then the affordability of the tool says, well, you can look at it as text. And that's okay when you want to type something, but when you want to read, it's no longer okay. So, well, here, because we don't go to a tool, it's the tool that comes to us. Then we say, which tool do we want to come to us? Right? So, and this is then the process with everything. So, because this is a language, so you parse it, you get some representation of objects, and then you can go and manipulate it. So here we have actually done a very small static analysis. It's very simple. Now, of course, we can do the same with JavaScript code. So here, if I'll take, for example, I don't know, this app.js. Okay, this is actually JS6. But we can also do JS6 actually. So here I have a JS6 parser, and if I parse with this one the contents, it will give me an actual syntax tree over here. So I don't get now from the JSON I got a nested dictionary. From this language I get a tree, and the tree knows how to present itself. So if I blow it up a little bit here, I can click there, and then you can see the abstract syntax tree here on the right. So I can say, okay, this is the import token, and these are the from, and this is even the semicolon. Okay, that's a problem there. But basically that's it, right? So I went from something that is textual, and I made data out of it. And now we can, if this is the data structure that I care about, then I will go and do the analysis there. So this is now a tree, but very often we'll find ourselves wanting to do or wanted to reason about the graph, so dependencies. And in the case of dependencies, we will be we need to import the data and do a little bit more something we call importer that takes the tree and transforms it into a graph, which is pretty much what most tools that get some JSON over the wire, or maybe XML or some tree-based data structure. What they do is they will parse that one, build a little tree, and then create a graph because you want to resolve the IDs and whatever. So you will build the graph in memory, and then you want to play with that one. And it's the same thing with code. There's nothing really different. It's just the only difference is what the meta model is, what the model of the data that you're playing with. It just happens to be a model of code. And then using exactly the same tools, or very similar libraries, you will be performing static analysis. So it's this idea that people are saying, I've heard this argument many times that but normal developers don't know how to write analysis, and that's terrible because it's simply not true. Because most applications today are doing exactly this, but not with a code model. Usually with a much more complicated model. So like normal domains, they will have easily hundreds of entities. In a code model, you will have less than that. So, well, of course, if it's not C++, but yeah. So yeah, that's the philosophy.
So this sort of file system access is very exciting. Is it also possible to sort of run programs which are outside the image and capture output? Like in Linux, I'm very used to using this on the command line, right? Like where I might have a Python script or some other shell program. So does this support that kind of workflow? Like, can I think of it in those terms?
Definitely. Is this readily available out of the box? If you know what you're doing, yes. Will it be significantly better in the near future? Very likely. But that's the direction we are going towards. So much of what I showed you here uses the Faro as a runtime. But we want to communicate with the outside world. So one example there is, let's say, a REST API. So for a REST API here, we just take this kind of, it's just a lorem ipsum for JSON, for just giving us some JSON over REST APIs. And so basically here it says, here's a to-do. If this URL, or you can give me the posts for these users, or give me the to-do number 8 here, right? And you will get this kind of JSONs. And so, okay, this is a little bit of a tutorial over here, but that doesn't matter. Here I have a playground where I have said, I want, given this client for this API, the to-do client, give me all the to-dos. And so what this one does, in fact, if I look in it, it's basically doing a request URL, which simply uses a library for, getting a URL from, getting this URL, getting the data from this URL. This is the URL that I put in there, and then this will give me a JSON, and if I do if I parse that JSON, I'll get my dictionaries, and then out of that dictionaries, I will be creating to-dos. And so now I'll get here a to-dos group, and the to-dos group, if I look at how it's implemented, it basically composes a to-dos array. Now, why do I have a to-dos group? So, because if it's just a wrapper over an array, because I wanted to have a view. And so what's interesting about this process is that once you want to create narratives about your system, and that's the driving force, then you will find yourself reifying first-class entities at very small granularity out of necessity, not because of a moral argument that this is how the best way to represent software is. It's simply all incentives are aligned such that you create better designs or finer grained designs, and you'll have little tiny objects everywhere simply because you will want to visualize every little detail. And because we make it profitable, then you end up creating these types of things without, having the clean code police next to you saying thou shall create small classes. Right. So this is a different way of working with the human brain. So then here, for example, right, I wanted to view such that I can see here there's to-dos from multiple users. And if I click on user number 1 here, what this one does, it actually did another call over the REST API and got a user back. And here now I'm seeing the to-dos for this user, right? And the posts for this user, or the albums. And now if I go in this album, if I look at that, then notice how the album, for example, shows me photographs. And now these photographs are being lazily downloaded now from the remote service. And these are it's just, as I said, it's just a lorem ipsum demo, but it does exactly that. Right, so this is a case where we are working, where the execution does not happen on the Faro client, right? The face API type of thing was similar. But now, of course, we also want to work with libraries maybe written in JavaScript or in Python, and delegate to those. So we already have integrations for a number of those, but we also want to provide the bridges, or we call it link, such that you can go and communicate with the VM virtual machine running some other language, but in a way that you can get proxy objects that you can nicely communicate with. So as if those objects would be in the image. And then you'll have, that's the prerequisite anyway that is needed for creating a development environment for another language. Okay. Does this address the questions?
It does. It addresses my questions and a lot more. It's very exciting, the sort of things that are possible. So now I look forward to playing with these.
Great.
Yeah. Thank you so much.
Well, thank you very much for your time, and see you in the community.